Hey, all your sins. Let's see this question of kinematics from Pathfinder. It's a check your understanding question number 36. Question states, four identical rods are hinged at their ends to make a parallelogram ABCD. The hinge joint A is rigidly attached to a wall and the opposite joint C is pulled away from the wall with a constant acceleration A as shown in the figure. Initially, joints A and C were coincident. Find the acceleration vector of the joint C at the shown instant. Though it is a very good question of Pathfinder, but Pathfinder has committed a slight mistake in writing the answer. So they have given x and y axis as shown here. So the mistake in the answer is in the y component of the acceleration of B, and that I will explain while proceeding for the solution. So let's proceed for the solving. So this is the diagram given in the question. C is being pulled with a uniform acceleration A, and let me assume that the length of each rod is L. But at the starting, A and C were coincident like this. From this state, where everything was at rest and A and C were coincident, the C is being pulled with a uniform acceleration A. So from this state to the state given the question, the joint C has traveled this much distance. And you can see this is L sine theta, this is L sine theta. So C has traveled from here to here a distance of 12 sine theta with a uniform acceleration A. So C will get some velocity, and let me assume that velocity is V0, and we can get that velocity by third equation of motion. So V0 square is equal to initial velocity 0 square plus twice acceleration A into 2L sine theta. So the V0 would be square root of that whole thing. So that will be twice square root of AL sine theta. And let's just consider the motion of this rod AB. The joint A is fixed. Joint A is fixed. This length is a constant. So B will move along the circle like this, something like this. So B is moving like this. So B will have some x component and the y component of the velocity. Here, the B will have an x component here and the y component here. The x component of the velocity of B would be clearly half of V0, because at any moment the x coordinate of B is exactly half the x coordinate of C. So x component of the velocity of B is simply Vx is equal to V0 by 2, and that would be square root of AL sine theta. For the y component, this constant will help us. The resultant velocity is perpendicular to the rod, and this angle is theta. So this angle will also be theta. So Vx and Vi are connected by this constant. This Vy would be Vx tan theta. So y component of the velocity of the rod is x component velocity multiplied by tan theta. So put the value of Vx here. So we will get square root of AL sine theta into tan theta. So overall velocity, if I want to write that VB, not required, but still for the analysis of the direction of acceleration, so that VB is equal to Vx sec theta. Actually, VB is equal to Vx is equal to VB cos theta. So VB is equal to Vx sec theta. So it means that is a square root of AL sine theta into sec theta. Sec theta is 1 by cos theta. You can see that as this whole system is moving, this theta is increasing. This theta is increasing mean this VB is also increasing. Sin theta is increasing, cos theta is decreasing, so VB is increasing. So if VB is increasing, so it will have a tangential acceleration in the downward direction. Because its motion is circular motion, so it will have one acceleration, one tangential acceleration, the velocity of this in the direction of velocity, and one centripetal acceleration. So the centripetal acceleration is along this direction, tangential acceleration is along this direction. So they will have some x component of acceleration and the y component of acceleration. So because the net acceleration, centripetal is along this direction, tangential is along this direction. So acceleration along y direction must be downward direction. So that is where the Pathfinder has error. In the answer, the acceleration is given the positive j cap. So that is not there. So now I have drawn the diagram for the acceleration. Clearly, the acceleration of B will be in the downward direction because this Vy is increasing. From here also, you can see that Vy, this is a, in the Vy expression, there is a sine theta and tan theta comes. And as the system is moving, theta is increasing. So Vy is increasing. So Vy increasing means if the velocity is increasing, so acceleration has to be in the direction of velocity. So now, from the same analysis, A and C started from the same point. In a given time interval, at any interval, the x coordinate of B is exactly half the x coordinate of C. So velocity of B along x direction is exactly half the velocity of C along x direction. So that we had got Vx was V naught by 2, and that got square root of AL sine theta. And Vy was tan theta times Vx, so that was square root of AL sine theta tan theta. Ax of this will be exactly half of this because its x coordinate is always the half of the x coordinate of C. So Ax is equal to A by 2. That is fine. For the Ay, suppose this is y, this y coordinate of B is y, which is L cos theta. So for that thing, I've decided that the magnitude of this B is Ay and its direction is the downward direction. So for Ay, I can write Ay is equal to Vy dVy by dy. And that will do in the next page. Magnitude I will take care of, and the direction I know it's going to be the downward direction. So Ay is equal to Vy dVy by dy. So Vy is equal to square root of AL sine theta into tan theta and y is equal to L cos theta. You can check it here. Y is equal to L cos theta. And this I can write Vy, and this would, I can write dVy by d theta, and this dy by d theta. So first let me calculate dVy by d theta. So differentiate this whole thing with respect to theta. So take a square root of AL outside and use the product rule. The square root of sine theta, that will be square root of 2 sine theta into cos theta, and tan theta as it is, plus root sine theta, and that would be how much? Sec square theta. So here root AL, and you can see this tan theta is sine theta by cos theta. So cos theta into sine theta, tan theta is sine theta, and in the denominator there is a root sine theta. So this is actually root sine theta by 2, and this is a root sine theta sec square theta. So that is square root of AL, and I'm taking that root sine theta outside. So overall that thing will come here, and here 1 by 2 plus sec square theta. For this part, I can do here itself on this page. Dy by dl is nothing but minus L sine theta. So put it, all these things here, next page. So Ay, in the Ay first there was Vy, and Vy is root AL sine theta into tan theta into this thing d Vy by d theta. We got this thing, so that is a root AL sine theta 1 by 2 plus sec square theta, and divide by dy by dl. I am interested only in writing the magnitude because direction I have decided. So that is a L sine theta, and now that is going to be this AL sine theta divide by L sine theta. So this thing, and this thing will just become A. That sine theta will get cancelled, and L will get cancelled, and take tan theta inside this bracket. So that would be tan theta by 2 plus tan theta, and for the sec square theta part, make it 1 plus tan square theta. So this is A tan theta, and tan theta by 2, 3 by 2 tan theta plus tan cube theta. So we got the answer now. So I can write A is equal to mod AX I cap plus mod AY j cap. Mod AX, that is clear that in the x direction, acceleration is along the positive x direction. So x component of acceleration was simply A by 2. That is A by 2 I cap plus from here. We had decided that this acceleration is along the negative direction, and actually it had anyway come because it had come with a negative sign. So minus here, put minus here, and that minus. That is A 3 by 2 tan theta plus tan cube theta and j cap. So that is our final answer.